Across the vast and varied landscape of California, from fertile valleys and earthquake-prone mountains to sprawling cities and fragile wetlands, the United States set out to build something it had never successfully completed before, a true high-speed rail system. Designed to move passengers at speeds exceeding 200 miles per hour, the project promised to reshape transportation, reduce emissions, and connect the state's largest regions with unprecedented efficiency. This was not meant to be an ordinary railway. It was meant to be America's answer to Europe's bullet trains and Asia's high-speed networks. Instead, it became one of the most delayed, controversial, and expensive infrastructure projects in modern U.S. history. This is the story of the California High-Speed Rail, a project defined as much by engineering ambition as by political complexity. The original vision. California's transportation problem was clear. The state's population was growing rapidly, highways were clogged, and air travel between cities like Los Angeles and San Francisco was inefficient and carbon-intensive. Engineers and planners proposed a bold alternative, a high-speed rail line connecting Northern and Southern California in under 3 hours. The plan promised clean energy, reduced congestion, and economic development across inland regions that had long been bypassed by major investment. In 2008, voters approved funding for the project. The vision was ambitious and the mandate was clear. What followed, however, revealed how difficult mega projects become when engineering meets reality. Why California is one of the hardest places to build. California is not an easy place to construct infrastructure. The state sits atop multiple seismic fault lines, including the San Andreas Fault. Any rail system must be designed to survive major earthquakes without catastrophic failure. This alone requires advanced structural engineering, flexible foundations, and extensive safety modeling. Beyond geology, the terrain itself poses challenges. The rail corridor crosses mountains, valleys, agricultural land, dense urban zones, and protected ecosystems. Each region requires different construction techniques, environmental studies, and legal approvals. Building fast trains is difficult. Building them in California is exponentially harder. Starting in the Central Valley. To simplify construction and reduce initial costs, planners chose to begin building in California's Central Valley, a flat, inland region dominated by farmland. From an engineering standpoint, the valley offered advantages. The terrain was relatively level, long, straight alignments were possible, high speeds could be achieved more easily. But the decision came with trade-offs. The Central Valley is also home to extensive agricultural operations, irrigation canals, and rural communities. Acquiring land required negotiations with hundreds of property owners. Legal challenges followed, delaying construction before it even began. Engineering a high-speed rail line. High-speed rail is not simply faster conventional rail. The track geometry must be precise. Curves must be extremely wide. Grades must be gentle. Even small deviations can affect safety at high speeds. Engineers designed the system with dedicated tracks, fully separated from roads and freight lines. Hundreds of bridges and viaducts were required to eliminate level crossings. Trains would glide over farmland on elevated structures, maintaining speed and safety. Every mile demanded precision, earthquakes, and structural design. One of the project's defining challenges is seismic risk. High-speed rail structures in California must absorb ground motion without derailing trains or collapsing. This requires flexible columns, sliding bearings, and energy-dissipating systems embedded into bridges and viaducts. Engineers modeled thousands of earthquake scenarios, designing structures that could move without breaking. Safety margins were far higher than in regions without seismic risk. This level of engineering increases cost, but without it, the system would be unusable. Environmental review and legal battles. No aspect of the project slowed progress more than environmental review. California's environmental laws require detailed studies on wildlife, water systems, noise, vibration, and land use. Each segment of track demanded its own analysis, often spanning thousands of pages. Opposition groups filed lawsuits. Local governments raised concerns. Routes were revised repeatedly. Every revision triggered new studies. Engineering timelines stretched from years into decades. Cost escalation and changing plans. When first proposed, The project's cost estimates were far lower than they are today. As designs matured, realities set in. Land acquisition costs rose, seismic requirements increased, construction prices climbed, environmental mitigation expanded, political leadership changed, and with it, priorities. Segments were delayed, endpoints shifted, funding became uncertain. The project evolved from a single unified vision into a series of disconnected construction zones. The role of viaducts and structures. Much of the rail line in the Central Valley is built on elevated viaducts. These structures allow trains to pass over roads, canals, and farmland without interference. Each viaduct consists of reinforced concrete columns supporting long spans of precast segments. Precision is critical. Columns must be aligned perfectly to support track tolerances measured in millimeters. Building hundreds of these structures simultaneously requires industrial-scale coordination. This is infrastructure built not in miles but in systems. Technology without trains. Another challenge lies in sequencing. Tracks are being built before trains are procured. Power systems are designed before final operating plans are locked. Signaling technologies must integrate with rolling stock that does not yet exist. High-speed rail is an ecosystem. Building pieces out of order adds complexity and risk. Yet construction continues because stopping would cost even more. What has been built so far? Despite delays, significant progress exists. Dozens of bridges and viaducts now rise across the Central Valley. Earthworks stretch for miles. Track foundations are visible from the air. From an engineering perspective, the system's core structures are taking shape. What remains uncertain is when and how the full vision will be realized. Why the project still matters. Critics call the project a failure. Supporters call it unfinished. From an engineering standpoint, it represents something else entirely. An attempt to build world-class infrastructure within one of the most complex regulatory, political, and geological environments on Earth. Few nations attempt high-speed rail for the first time under such conditions. California did. A question of time, not possibility. High-speed rail works everywhere it has been built correctly. The question in California is not whether it is technically possible, it is whether political will, funding stability, and long-term planning can align with engineering reality. Mega projects do not fail because of concrete or steel. They fail because systems surrounding them collapse. Engineering versus governance. The California high-speed rail project exposes a fundamental truth. Engineering can solve enormous problems, but only if governance allows it to proceed. When vision fragments, timelines stretch. When leadership shifts, priorities blur. The trains have not failed. The system around them has struggled, outgrow. So now you've seen the real story behind California's high-speed rail, a project defined not just by engineering challenges, but by the complexity of building at scale in the modern world. Do you believe projects like this are necessary investments in the future, or warnings about ambition without alignment? Let me know your thoughts and join me for the next story of engineering shaping and testing our world.